All right. Can I kick off so that we can optimize the time? Okay, then we need to kill the background music. Oh, I hope that's not coming from my hand. Oh, that's coming from mine. All right, forgive me. All right. All right, gentlemen, good evening. Gentlemen and beautiful ladies, let me start there. All right, good evening. Welcome to another amazing session in season 2 of AISOC. Yeah, so before I kick start, I would like to get to know everyone that's on the call. I know we'll be getting a lot of interaction with ourselves as time goes on. So let me use this as an icebreaker, right, to get us really engaged in. Why did you opt in for LLM engineering? Let's use the chat. Let's start from there. Let's use the chat. Just tell me, why did you opt in for LLM engineering course? I mean, there's no stupid reason, right? So just feel free to give me your reason. I mean, there are many reasons people do things. There's some disappointment driven. So it is family pressure driven. So it is my friend driven, right? So why did you opt in for LM engineering course? I want us to just use like 2-3 minutes to do that. To go to, let's use that to get to know the whys. It kind of like helps, for you especially. It helps to shape. We have applied AI members say, I said, okay, great. Why did you opt in? But if whatever track you choose, right, whether it's not your track, whether this is a borrowed course, whether it's your main course, why did you opt in? Or you just AISOC force it down my throat? That's actually an option, right? You can put it there and say AISOC force it down my throat. I didn't beg to do LLM engineering. They force it on me because I choose my course. I just saw it. When anyways, you just see some courses that show up in your calendar and you're like, I never wanted to do GST in my life. I don't want to be a teacher. Okay, my own job became too boring. I mean, yeah, that's some serious valid reasons, right? From time to time, your job can just get boring. You want to do something that will shoot you to the next level. That is an absolute valid reason. Everybody gets in that position, and you want to learn something crazy, right? To just get there. So I mean, Martins, thank you, Martins. We have about 17 people on the call. I don't want to assume that I'm just speaking on the pulpit or speaking from a stand, and people are just listening and doing their own stuff. I like to see the engagement. Yeah, I want to become prompt engineer, but I need something deeper. I mean, that's cool. That's super cool. But I mean, honestly, if you can say AISOC forcing down my throat as well. It's a borrowed because I don't want to do this while I'm here, and it's a 3-unit course or a 4-unit course. But yeah, I mean, yes, it's also great to have a new skill in your belt. It makes you really want to go into freelancing. Amazing. The good thing about having such skill in freelancing is that the opportunities become very, very wide for you. I opted for the applied data type because I wanted to learn something that is of almost immediate value in the job market. Spot on, hope, right? Again, it's great to learn something that is really, really relevant, right, in the market. For me, as someone who has worked for the better part of my career, as well as a software engineer, and also a better part of my career as an AI engineer, moving to senior AI engineering, I can tell you for free what it adds value in the market. Is a good way to work your way up financially. Awesome. It is an in-demand skill in the market. Yep, I agree. I am in ML and I need to add LLM to my skill. Awesome. That's great. Okay, so I think we can work with what we have, right? But if you've not sent in your reason, do send it. I'll take my time to read it as time goes on. All right. So who am I? Yeah, my name is Sam Ayo, and I'm a senior AI engineer. I began my career actually in software engineering some years back. And then after a couple of years, I moved into data science. With data science, I began to pivot. I spent a lot of my time working with large-scale systems, building AI systems, building AI models, deploying them, managing them in the cloud, and scaling them as well across different domains. I've worked in insurance, I've worked in health, I've worked in finance and fintech. I've worked in IoT. I've worked in agri-tech. I think a whole lot of them, so I can't even remember off my head except where the opportunity presents itself. I did spend a couple of my time dabbling around economics, mathematics, and statistics to harness myself with a couple of certifications as well with American Board of Artificial Intelligence and then Microsoft as well. Yeah, so that is me in a nutshell. I'm currently a proud father and dedicating my time to building and nurturing talent for the next generation, which I believe is the next big thing. All right. Today, again, is not going to be as deeply technical as it will be today. Is that time where you're starting your car and you just want to ease in and then kick before you go full throttle on the road. So we'll be looking at large language models. We'll be looking at what they are, right? We'll be looking at demystifying the buzzwords. We'll be looking at the concept of large language model. Then we'll look at LLM engineering and really who is an LLM engineer. I mean, there's a lot of buzzwords. As a matter of fact, these days you can't just breathe. Anywhere you turn, there's LLM everywhere. Right, and I know it never used to be this. So, as a matter of fact, data scientists now begin to wonder because in those days they say data scientist is the sexiest job of the century, and everybody wanted to just do data science. They say if you say I'm a data scientist, everybody's like, oh, you're so good, you're so wonderful, you're the best, right? But now everything just seems like there's a new kid in the block. Is everything just takes a whole different new turn, and that's the thing about AI and the ecosystem, right? There's a trend, there's a wave, and unfortunately, for each trend and each wave, you get to realize that as the trend and the wave progresses, there are people who capitalize on it to sell the hype, and there are people who capitalize on it to sell and nurture the talent. Right, so you need to differentiate which of which. But then, what really is large language models? And again, it provokes the thought of the idea: if there is a large language model, was there language model, or no, let's say, was there small language model, or was there tiny language model before we start saying large language models? And the truth is, as a matter of fact, there was, right, just language models. And we use them almost every day in our life. We did not just know, right? We did not just know that they were there. Well, the reason because they did not exhibit very strong capabilities, right, as large language models are because of some parameters that will exercise and work with and massage throughout the duration of your LLM engineering course. And then we'll then demystify some of these buzzwords that you see people throwing at left, right, and center: GPU, context memory, context window, and that's for LLM in the cloud, right? And when you look at LLM, working with LLM locally, you see some big context words like managing float memory, key token, key value chain, you know, and all the likes like that you need to manage by yourself, right? And then you go to the part where you are managing the tokens, you're checking the language model size, you're comparing it to your GPU, you're stacking GPU, you're managing GPU, you're monitoring your GPU usage, you are sharing GPU, you are sharding memory, you know, all those big buzzwords that you read in the blog and you are beginning to have a headache. We're going to break majority of them down within the time constraint and time limit, and then look at all the rest as they go. Then we'll look at how do LLMs really work and what is the concept behind them, right? Because the goal of you moving through this LLM engineering course is not for you to become people who just write API plus ChatGPT or Claude API. It's for you to understand how does this thing work under the hood, right? Because majority of the time when you go to work, you might come across organizations that do not rely on LLM in the cloud. They rely on managing their own infrastructure and then scaling it by themselves. right? So what do you do in that case? You already said you went through AISOC, you're an LLM engineer, right? So then we'll look at what really is LLM engineering itself, and then really who is an LLM engineer? What does it mean to be an LLM engineer? Am I just another AI engineer or another ML engineer, or perhaps a software engineer that has gone to rebrand and change his clothes and I'll say I'm now an LLM engineer? So we'll look at all these things as we go. All right, so let's start with what are large language models actually? So I think let's use this again as an opportunity to take advantage of the chat. What are large language models? So give me your idea. I know I'm already showing something, or let me help the class, right? Let me help the class. What are large language models? Just give me your idea. Don't go online, right? We are not relying on ChatGPT here. We're about to study ChatGPT. So what are your ideas of large language models? What do you think about large language models? Let everybody's finger start typing. Start typing. What do you think about large language models? I know you must have come across, you must have used ChatGPT. Everybody has used ChatGPT. So I'm not going to treat this class like it is introduction to Python, right? Models with billions of parameters with longer training times. Good. I mean, that's a fantastic good start. Models with billions of parameters. Okay, guys, I think I already know some of your names from the chat, so I will start calling you out, right? Daniel, Kingsley, Obina, I will start calling you out. I can see your names. So you will just see your name. Your name will just start filling out from my mouth. So go ahead, right? And let me know, what do you think are large language models? There are no wrong answers again, right? So you don't really need to try to give the best answer. It's just to get you thinking, right? Large language model, yeah. Thank you, Siva. Language models work by predicting the next word. LM to the same thing at the large parameter scale. Awesome. All right, let's go. The models behind the chatbots we use today. Yep. All right. Guys, I expect to have this chat buzzing, right? Here's Martins, right? Let's have a chat. Let it be buzzing. I want to see you guys commenting. That's how I know that I'm not giving a, this is not a keynote, right? It's not a keynote where you just sit down and you just listen. It's a classroom. So what do you think are large language models? What are large language models? What do you think in your head, right? When you imagine about large language models, what comes to your mind? Okay, I think LMs are models that are trained on millions of billions of parameters to predict next word or sequence in languages. All right, great. Group of billions of models. Okay, I've been hearing everybody saying models. Really, so somebody should help me here. Like, what are models? When you guys say models, what are you referring to? What are you referring to? A model trained on large data set to predict next word. Okay, great. When you say models, what are you referring to? Algorithms. Okay, what are algorithms? When you say algorithms, what are you referring to? Rules. Okay, but when algorithms trained on data, okay, they are a type of AI designed to understand and generate human-like language. All right, summarize large documents. Okay, so when we say, I think I like the flow, right? It's really exciting, right? So when we say algorithms and we say models and we say rules, right? We are converging on the same concept, right? In the case of models as replica of a thought, models as replica of a thought process interest, I think somebody should just create thought process and just replicate them, and let's just start having models right now. Okay, great. When we talk about models, right? When we talk about models and we talk about LLMs in context of this, we're talking about neural networks. You know, the funny thing here is that hype, AI hype, has made these things feel like they are really out of reach. It makes it feel like it's out of reach. But when you think about large language models, first take away the large, right? Because it kind of makes this a bit blurry, right? And then come down to language models. And when you talk about language models, you then have to separate language and models. And then let's start with models, right? Now, models in its form of itself is actually an algorithm trained on data, right? And I'm sure we also learned that in the previous session, in the introduction to machine learning that Daniel took, awesome session, by the way, right? We also learned that. And then we get to realize that in this algorithm you're talking about, this algorithm that is used to form a model in the context of natural language processing, right, is actually a neural network. In this case, a neural network, you could either design a neural network depending on the different kind of architecture that are available out there. Now, we're not talking about natural language now, we're talking about focus on neural network, right? So we're going to walk backwards, right, from the basics, then we'll walk back to language models, and then we'll continue our journey from there. All right. So when we talk about neural networks in this case, let's start with a basic convolutional neural network. Right, you set your filters, you like time your matrix depending on your type of data you're working with, your dimension of your image that you're working with, and then you examine the filter, and then again, the deeper your neural network, right, and the layers and the controls you put in there. Controls in this case means the loss functions and your monitoring of your descent and the likes determine how buoyant your model is, right, in the face of comprehensive data again, right? Because there are a lot of clauses in these things. You have a neural network that is based off a convolutional network, for example. Now, but when we come to the case of when we talk about language model, now not vision models, right? Vision models will largely depend on convolutional neural network on the baseline. But now, in the case of language model, we're no longer asking a computer to create visuals based on numerical representation, right, of an image. We're trying to make it understand not just word sequence, but context, nuances, and semantics in a word sequence. And so that exactly is the big purpose behind language model. Again, we're not talking about large language models yet. We're focusing on language model. What makes language model super unique, right, in the context of AI? It is because language models are now designed in the scope of them being able to understand the semantics, the nuance that applies to word structure in terms of conversational understanding and interpretation. So initially, right, a normal model is just given a sentence, it looks through it, it does not understand what it means. It just looks through it and responds back based on the algorithm design, right? But then for language model, we have introduced some certain methods we studied throughout this course to give it a sample, right, or a make-believe. Again, I use the word make-believe by choice here because in the reality of things, models cannot think. I know it's going to come as a shock. LLMs cannot think. In the reality of things, they cannot think. Because the ability to think is a different concept entirely on its own. So we're going to get there and we're going to break that down. But for now, because we are breaking the foundation, right? So it gives them like a sample of or a make-believe approach, right? That they understand what is being communicated. So the way for them to be able to do that is to apply these nuances that they're able to understand, right? In this case, and that is the holy grail that they call the attention mechanism. We're going to break that down as well, right? We're going to do it from step by step and time to time. So let's walk our way backwards. We've looked at what a model is, right? Thankfully, you guys have also elaborated that in the chat. A model is actually an algorithm that has been trained on a large data. It can either be an image data, which is structured or unstructured data. I hope you guys understand structured and unstructured. Just say yes or no. You understand structured and unstructured data. Awesome, great. So now, either you're using structured or unstructured data, you've trained your algorithm on a data set, and you now have a model. Now, to bring that into the scope of LLMs, you're not working with vision, you're working with numerical understanding, right? Numerical understanding, in this case, natural language processes for this. So your data set in this case will not be images, there will be words, corpus, a collection of words, characters, right? So you use that to train a language model to be able to understand that. Then in the scope of a large language model, it is a neural network, right, that has been trained on a large amount of data, and the goal being that to predict and generate plausible language for multiple purposes, right? So in this case is why you have like language models being able to be finding use in chatbots, finding use in conversational assistants, finding use in agentic AI, finding use in medicine and the likes, being able to look through medical documents and be able to make interpretations of them, right? So the large in the language model is on two lanes. The first lane is that the neural network has been expanded from something small to something very big. In this case, from your deep learning class, which I believe, I want to assume you understand, but of course, I will take the liberty to also touch some of that, but lightly throughout the course, is that the network has been made deeper, right? The network has been made deeper so that it is able to train more and see more representations, right, of the data that is being provided to it. Then the data has been provided to be more richer, right? Again, from your big data class, which I'm sure you still remember, you remember the V's, right? Velocity, variety, and the likes. Right, so the data is wide, covers and touches a wide range of topics, right? And then the model is trained on this, so it can create weights from this. Now, let's go back, right? So we're not moving too fast. A language model, again, is a neural network that is trained on a large amount of data with the sole aim and goal being to predict and generate plausible language for multiple purposes. You can consider it to be an advanced AI system, right, of complex neural design. It can understand and generate, right? It is trained on massive amount of data, and it looks through patterns and rules to be able to map to languages to be able to understand them. Okay, so how did we really get here? You know, for someone who is born in this day and time, you just get to realize that you wake up and there is one day that you wake up and then you realize that people are just using ChatGPT, right? And then you kind of like look and say, where did all this start from? Where did all this AI, what does all this AI start from? Right? How did we get here? Right? How did we get to the AI that we're experiencing right now? Or how did ChatGPT bring us here? Because you know, the funny part is when you ask people what is their first encounter with AI, they kind of mention ChatGPT, right? But the truth is, I never really began from ChatGPT. It began way behind. And again, as a student here on AISOC, one of the main goals is not just for you to understand what is now, but for you to understand what was. Because you cannot really create or design new systems or work in systems if you don't understand what was, right? So how did the AI get to this place? It began with ELISA, right, in the 1950s, one of the very earliest times of natural language system designs, right? When these systems were being designed and created, excuse me, as at that time, right, the knowledge was still very young, right? Systems were being designed at a very young time. And then from ELISA, around that 1950s, 1960s, and after that time, it was basically just mild research going on, right? Mild research going on. And that was majorly championed by MIT, right? I think that was really being done by Joseph as at that time. ELISA in itself actually marked the beginning of research into NLP. And it provided the foundation for more structured and complex LLM systems that we have today. Now, fast forward, give around, say, 30 years later, or 30 plus years later, we had the introduction of LSTM, which is an acronym for long short-term memory, right? So as at the time of LSTM coming in, LSTM was a big deal, right? It was a big deal because it provided the LLM the ability for it to be able to perform and work with even much larger data and still be able to provide some level or some sample nuance of understanding, right, of context in conversations. It provided, the result was actually massive at that time, actually, because there was now ability for people to now see or look and understand deeper and more complex neural networks that is able to see through large amount of data and understand them. So after that time, it was like a hinting, kept on going on until NVIDIA introduced the first GPU, right? The first GPU in 1999. You know, right now, it's kind of like a big deal because NVIDIA stock is touching the roof and everybody is running left, right, and center with NVIDIA stock, hey, NVIDIA. But they've actually come a very long way, right, through system and chip design. So we had NVIDIA shaking the market at that time, introducing GPUs and providing the next level frontier for training large language models. Because again, these models are usually data hungry, right? They're data hungry. And then we moved on to 2011, right? After 2011, another breakthrough came in with the introduction of advanced features, right, for word embeddings. Conversion, that is a conversion of natural language text that is the words me and you understand into vector space, and then be able to compress them properly in proper representation to scale up computing and also provide the neural network more room to learn more and be able to provide more stronger inference. So after that went on, we now went into the era of transformers. Now, transformers is actually considered a very, very big deal. You can't see my screen anymore. Can you see it now? Okay, great. All right, so, and then we went into the age of transformers. Now, transformers became actually a really, really big deal as at the time. Even till now, it became a really, really big deal because the Google DeepMind team introducing transformers formed the groundwork for modern language models as we have it today, because it introduced it to the popular paper that's called Attention is All You Need, giving LLMs language models the capability to place attention mechanisms or place certain concentrated weights on certain texts in the entire corpus or certain vectors, right? And able to use that weight that have been placed there to be able to provide more better reasoning capabilities to the language models. So it was like a big turnaround as at that time, even till now, right, for modern systems. Why? Because it is on this same principle that ChatGPT and modern models are built on. Even Grok, right? Although Grok is not fully built, that is Twitter's Grok, where people say call it Twitter anyway. So Twitter's Grok is not largely, right, based on transformers, but it sits very closely, right, to the transformer architecture because it's a mix, right? It's a mix of both sides. Then we moved on from then to the introduction of BART, right? That is by the directional encoder representation for transformers that provided a very nice encoder-decoder capabilities for pre-trained transformers, moving the context of research forward and increasing the capabilities of language models, right? With around 340 million parameters as at the time, and providing a lot of variety of what could be done with unstructured data, especially in the face of unsupervised and supervised learning, right? So as at that time, BART became more of like the center tool for many uses, right? Many uses for intent classification, for simple chatbots, for language translation. But at that time, BART was like the craziest thing, right? It was the craziest thing. A lot of hackathons were done based on BART, right? I remember the DSN as well, right? And that's data science, the popular data science network now, right? So then on till now, everything that we experience now is layered on that. So I would have loved to put ChatGPT in this whole story, but when we talk about foundations of where it all began from this part, right? Everything that we now use now is layered on everything that you see right now, right? The ChatGPTs, the Anthropics, the Gemini, they are all built on this very foundation that we see right now. Okay, so let's talk about some buzzwords, right? Because of the sake of time and what I want us to cover today, we'll touch these three, right? Then as the session go on, we'll expand on all the others that are hidden inside of all of these. So let's start again, right? Let's start with the first one. NLP, LLM. Let's take to the chat. What do you think is the difference between NLP and LLM? What do you think is the difference? I mean, you hear people say NLP engineer. I mean, you must have come across NLP engineers, right? Somebody's an NLP engineer. So, and then an LLM engineer. So what is the difference between NLP and LLM? What do you think is the difference between NLP and LLM? Again, there are no wrong answers, right? I would always say that. So if you're afraid you're going to say, maybe say nonsense or say rubbish, do not be afraid of that. There's nothing like that. It's a learning community, right? And the answer you provide will just be what sparks curiosity in somebody else. So, and again, if you want me to call your name, I'll call your name. NLP is a concept. Okay, all right. What about LLM? What do you think? So look at it as, give me a kind of like a difference. NLP is this, while LLM is this. Okay, NLP is a field, while LLM is a model. A field of what? While LLM is a model. And natural language is text, while LLM go beyond text. Okay. Okay. Olawumi, Samuel, Siva, Victor, Daniel, Solomon, Obina, Nello, Miriam, Sherifi, Kingsley, Fidelis. Yeah, so let me hear what you have to say. Or else I'm going to target you. All my questions I have, I'm going to target you. If I don't see your name in the chat, I'm going to witch hunt you in the call. All right, so NLP does not have a please, guys, disregard that. NLP does not have a next level prayer. Okay, so LLM are just one of many tools used in NLP. All right, NLP is a model that extracts sentiments in the language, while LLM is a model that predicts the next word. Natural language is text, while LLM go beyond. All right. Let's keep having them, and that's good. I like the direction. Let's keep having them. What is the difference between NLP and LLM? Who has not chatted? Who has not dropped their response? I have not seen Solomon's response. I have not seen. Let me see. Hope, I don't think I've seen your response. I don't think I've seen the response of Miriam, right? Nello, I don't think I've even seen Nello's response anywhere. All right. Victor, I think I saw Siva. Samuel, I've not seen your one at any point. So, guys, I need to know that you are here. It's very important that we are on this call together, right? What do you think is the difference between NLP and LLM? NLP is all about processing languages, while LLM is a model under the umbrella of NLP. All right. NLP is a field in AI, while LLM is a model based on NLP practice and concept. Okay. NLP seems to be for small language models. Okay. All right. So I want to throw something in the mix now. What's the difference between NLP and NLU? Have you ever heard of the word NLU before? Difference between NLP and NLU. Anybody? If you've not heard of it before, just say I have not heard of it. Right. But if you have heard of it, what do you think is the difference between NLP and NLU? Never heard of NLU. Okay, cool. NLP is a broader field that involves language processing, while LLM is a more specific field that leverages. Okay, I have not heard of it. Oh, cool. NLP is a broader field on how computers understand language. LLMs are models used within NLP to train massive text data set to understand and generate language. Okay, cool. All right. So you can keep telling me, right? If you know something NLP and NLU, that's awesome. All right. So when we talk about NLP and LLM, right? Your answers again converge towards what it is. NLP, which is natural language processing, is a broader field of study in AI. It's a broader field of study in AI. While LLMs are specific implementations within that field, right? NLU stands for natural language understanding. So while LLMs are specific implementations within that field, right? Specific. So think of what term would I use to best explain this now? Okay, maybe I should use mathematics, right? Mathematics as an umbrella that is general and everybody knows, right? Then applied mathematics, right? It's specific within that particular field. So if a person says they are an NLP engineer, it's like they are saying that I can do all and everything, right? So there are specific fields within the NLP field that they are more focused on. All right. So again, NLP is natural language processing. It's a broader field. It's a broader field of study in AI that focuses on the understanding and processing of languages that is human readable and human understandable. While LLMs, the large language models, are specific implementations within the field of NLP. All right. Okay, David said NLU is synonymous with semantics. I'm just reading that your hyphen and sharp bracket are synonymous. If that's not correct, please correct me. But you're saying NLU is synonymous with semantics. All right, cool. So again, now let's take the next one. Generative AI versus LLM. What's the difference? Because generative AI is about to blow my head. Anytime I open LinkedIn, generative AI, generative AI, generative AI, generative AI. What is the difference between generative AI and LLM? What do you think are the difference, or is the difference between generative AI and LLM? What do you guys think? Generative AI and LLM, what is the difference between generative AI and LLM? What do you think is the difference between the two of them? Or are they the same thing? I don't think there's so much difference. Okay, if there's no so much difference, what are those differences? If there's no so much difference, then what are those differences? Generative AI generates new content, while LM is creates and understands text. Okay, please keep sending your own. I want to sit on Olawumi's point, right? Olawumi, so my question to you is, if generative AI generates and LLM creates, is creating not the same thing as generates? Maybe you should break that down in your next response. Please break that down. Let me understand that. Okay, so Hope said the AI goes beyond text to include maybe images, while LM is clearly on text. Now, I like this part, right? Because we're going to talk about this if I end this session, right? When we say image generation, what really is image generation? Generative AI is a broader category, while LM is specific to. Okay, generative modeling is basically trying to learn the underlying distribution of data and can be achieved through VAEs, GAN, evolution models, and LLMs. Okay, so Siva, what is the difference between generative modeling to generative AI and LLM itself? I mean generative AI, that's text content and others plus graphic. Okay. Sheriff said generative AI is a type of inference in deep learning models, while LLM is just a deep learning model that uses generative inference. That's a lot of English. Sheriff, please break that down. I want to know what that means. Generative AI is a broader part, while LLM is a subset of generative AI. Okay, generative AI involves models with convolutional neural network combinations, while LLM does not necessarily use convolutional neural networks. Okay, all right. So let's bring everything together. Let's break it down. So when we say generative AI, we're actually referring to an umbrella concept, right? An umbrella talk. It's like saying program or camp. AISOC is a program, right? But what really is AISOC about? So generative AI is actually a context or a concept, right, in the field of AI that focuses on designing models that have the capability to generate new words or new tokens based on their training data. Now, when I say new words and new token, I want you to understand that new words and new token in the context of LLM does not imply new knowledge. Generative AI has the capability to generate new words and new tokens, like new words and new concepts based off their training data. But that does not mean it is generating new knowledge, because again, they do not have the capability to generate new knowledge. So generative AI is LLM is a form of generative AI. Generative AI is not limited to images, right? So long that that model has the capability to generate new words based off of its training data, then you can categorize that system or that model as being generative in nature. It is not limited to GANs, it's not limited to VAEs, right? It's not limited, it's the context in this is the capability for that model to generate new knowledge based on what it already knows. So image generation models are actually large language models. Again, like because of the content, like, there are some things I want to really break down, but this is an introductory class, right? We'll do that as the session goes on. Now, okay, so Solomon said, okay, I think I've read Solomon's message. Yeah, okay, allow me said, LM is specific within generative AI, that is input output is text to text. All right, great. So yeah, so that's why if you use Hugging Face a lot, right, which is what you're going to also interface with a lot throughout your program, you find that they have taken the time to specify different categories of this in their portal, right? Where you have text to text, image to image, text to image, right, image to text, and the likes and the likes. So because they are generative in nature. All right. Now let's move to the next one. GPU. What do you understand is GPU is all about? What do you think GPUs are? Right? What do you think GPUs are? I'm trying to maximize the time, right? So I want us to just move really fast. Let's move really fast. What do you think GPUs are? If it's the first time, again, if it's your first time hearing it, say, this is my first time, right? If it's not your first time, tell me what you think GPUs are. What do you think are GPUs? So GenAI doesn't even generate outside the thing. Of course, yes. I know that's kind of like very funny, right? But it is always within that scope. It never leaves it. Just as a side note, please keep your GPU coming in. Just as a side note, right? That is why Elon is stunting, right, or touting throughout the entire AI community that Grok has the capability, or is currently being trained to have the capability to be able to create new knowledge or create new historical data for the earth. But that's really funny because you cannot create new knowledge from the data or the knowledge that you already have, that you have been trained on. How do you do that? You have to do that outside the scope of your training data, right? So it means Grok has to train outside Earth or train on the universe and then come back to us. Right, so okay, so GPUs are graphic processing unit. GPUs are large processors with large processing powers. Okay, GPUs are dedicated for training deep learning models. Love that. GPUs can run large numbers, okay, of processes in parallel. Beautiful. All right, so yeah, so you guys have really put it in perspective. GPUs have the capabilities, right, to scale beyond the limitations of CPUs in itself, right? Leveraging the very strong power of parallel processing, right? Parallel processing. They leverage that parallel processing to be able to scale models and be able to assign tensors, right? The ability for them to be able to run this in batches, right? And that's what makes them a really, really big deal to CPU computing. Okay, I have about 9 minutes. Let me raise my time. Okay, so let's just quickly talk about GPU means dedicated to training. Okay, I think I already read that. Let's talk about how do LLMs work, right? How do LLMs work and the concept. Again, right, this is an introductory call, so majority of all these things, I have watered them down a lot, right? I've watered it down a lot in the course of your session, right? As your program progresses, all of these things will be taken and they will be broken down into their correct form, and then they will be taught, right? So how does it begin for LLMs? It begins from raw text coming in, right? These raw texts are then tokenized, right? So again, like I said, this was watered down because in the ideal way to look at this, we would have looked at from two parts: inference and training, right? So when we talk about inference, we talk about the time when it is giving you a response as a user, when you are consuming the LLM, right? So training is where the LLM is being created, that is an algorithm that's now being trained on a large corpus of data over a large number of GPU, right? I think according to Kapati, Llama 2 was trained, I think, over a period of 12 or 20 days, I can't remember correctly over, I think, about 12 or 20 days, right? Over, I think, I can't remember the figures, so I'm just going to give you a rough unverified estimate from my head that I can recall them, but I think there are around 6,000 or 600 GPUs that Meta used, right, to train Llama 2 as at that time. Now think about that scale. Like, imagine training. I remember then when I used to train with my old HP, right? I was not even training with GPU, I was training with Steam. Right? I'll be training and my system will be making crazy noise. What am I even training? I'm not even training with large data. I'm training the chatbots, right? I'm doing a chatbot using Stacy and NLTK. Right? So now imagine doing that for 12 straight days or 20 days stretch, right? And the model is just training, it's just training, it's just training, it's just training, it's just training. What really happens there is the data set is prepared, and then the data set is tokenized, and then the model is trained on this tokenized data. So when we say tokenized, what are we really talking about tokenized, right? Tokenization refers to separating data into different clusters, or separating words or characters, right, into different sections, different quota, depending on the embedding model that is being used to convert it to embeddings. Now, again, this is usually done based on normal human language or human understanding of what these things are, right? And again, as a function of how the model is, the algorithm that is being used is able to assimilate or train over data as per given time, again, as a result of the GPU. So there are a lot of things involved: GPU size, GPU number, algorithm of choice that is being used, data set and domain that is being used to train, right? So they are all being considered. Then that's now being used to determine how the data is being converted into tokens. It's broken into different characters, and then that character is now converted into the numerical representation in vectors, right? And then that word vector is now further converted into context vectors, right? That context vectors is then what is the model now computes probabilities on, to be able to understand and then create output for you. A good example is, if a model is trying to respond to you, that if you train a model and say A for apple, B for ball, right? And then you ask it, A is for what? It needs to look through the training data and look for the most probable, or the answer that has the closest match in terms of probability to A is for what. Again, if you see A is for aeroplane, if you see A is for Ada, if you see A is for adamant, if you see A is for, so it needs to look for which word has the closest representation to A is for apple, right? So in those days, pre-transformer architecture, that was really the biggest problem, because the LM would just say A is for aeroplane, or it would just say, or let me give an example. A man was once a boy, right? Now, pre-attention mechanism, that's before Google attention mechanism, the man was a boy. If you train a model on that and you ask it the question, the boy is going to be what? It's lost. It doesn't know. It is lost. If you give it the same question that is in its training data and say the man was what, it now needs to think based on probability, right? That is this answer supposed to be boy, girl, woman, man, car, based on what it learned a man is. And majority of the time, it always got it wrong. Until it began to, attention mechanism was introduced, it then began to associate that man is associated to boy, as boy is associated to man. In as much as there is some degree, right, to the relationship, but man is associated with boy. So if it has a problem, right, that it requires it to respond to man, it needs to consider boy before considering table, or considering car, or considering laptop. It must consider boy because boy is the closest in terms of probability to how to complete a sentence of that involves a man. Again, so it begins from raw text coming in. Raw text are tokenized. Are they tokenized? They are converted into vector representation of that, of per each character or per each word, depending on how the tokens are split. We'll look at this in depth. And then they form word vectors. Now that word vectors is now be aggregated to form context vectors based on attention, and then it then responds as an output. All right. So let's look at why we're here, right? ALM engineering. What really is LLM engineering? When we talk about LLM engineering in itself, right, we're actually talking about a specialized field in AI systems and model design that falls in the intersection of AI engineering and software engineering. And it includes the training, developing, fine-tuning, and deploying of large language models. All right. So when someone says I'm an LLM engineer, right, that person must be able to also come out and say, I can do AI engineering and software engineering, because that's what it really entails, right? And it covers the training, the developing, fine-tuning, and deploying of large language models, right? How many of us have heard about or come across the term LLM ops? LLM ops. Yeah, I think it's like this. LLM ops. Yeah. Okay, LLM ops. Great. Right. So LLM ops is actually stolen. I'll use that word, stolen, from ML ops, the original. Just the same way ML ops stole from DevOps. They're all stealing from themselves. And how DevOps stole from business nomenclature for managing business processes like waterfall and agile, right? So and that's how it flows, right? So an LLM engineer, you can actually summarize what is likely going to be from understanding what LLM engineering is. So before we close the class, I want us to just take that brief exercise and tell me, who do you think is an LLM engineer? Who do you think is an LLM engineer? Who do you think is an LLM engineer? So if someone says I'm an LLM engineer, who do you think they are? So you can explain it to me in terms of skill set, that's fine. You can explain in terms of capabilities, that's fine. But just give me your own idea of what you think an LLM engineer is. What is an LLM engineer? I'm not saying LLM engineering, right? That's clearly on the screen. I'm saying LLM engineer. One who can train, deploy, fine-tune, and one who can train, develop, fine-tune, and deploy LLMs. Awesome. All right, Siva, Samuel Olajide, Olawumi, I think Solomon just responded. Awesome. Obina, Nello. Nello sounds familiar. I think I know Nello. Okay. Miriam, Martins, Jan, Jerifi, Kingsley, Fidelis, Hope, David, Daniel. What do you think, or who do you think is an LLM engineer? Okay, is one that does everything. Does the person also do some of code? Because AI summer of code 2.0 is on the screen too. They also do AI summer of code 2.0. All right, so an LLM engineer is one who can train, develop, and deploy large language models. Great. A software engineer that can train, develop, fine-tune, and develop LLMs. Good. You know, there's always this argument going on that people say AI engineers, ML engineers are still software engineers, and AI and ML engineers are saying we are not software engineers. You know, there's this argument going on, and people are saying you are just software engineers. They say we are not software engineers. You know, there's this argument going on. So that fight you want to start, David, Daniel, I'm not there with you. I'm just here to take the class, right? That's fight you want to start. Okay, so a person who has skills in AI and software development to train, validate, and deploy languages. An LLM engineer builds and deploy production. Okay, an LLM engineer builds LLMs. Miriam, that your answer is just let my people go. Just release me, sir. Release me. An AI engineer that's focused on LLMs is someone who builds, fine-tunes, integrates, and deploys LLMs. An LLM engineer is a professional who specializes in designing, fine-tuning, deploying, and optimizing large language. DA, this is your first time responding, and you respond with a laugh. That's very interesting. Okay, right, great. That's a good one on what an LLM engineer is. You guys hit it really, really spot on. So when we talk about the skill sets briefly, right, what skill set is an LLM engineer meant to have? Strong programming background. You can't jinx it, right? You can't jinx it. You can't. You need strong programming backgrounds, right? And beautiful, right? That's one good thing about AISOC. Yeah. Yeah, you are going to code. You're definitely coding, right? So you need strong programming background. And you need core understanding of mathematics and statistics. You need core understanding of mathematics and AI. You need it, right? Very important. Like you need it because again, LLMs under the root. No, you can't vibe code. Okay, this is not you can't ask ChatGPT to create ChatGPT. How is it going to do that? It's like ChatGPT saw itself being created. So you need core understanding of machine learning and AI, right? You need the core understanding of machine learning and AI. Then you need good grasp of statistics and mathematics. You need a good grasp of it, like a good grasp. Now, again, if you notice, right, it says strong math programming background, core understanding of machine learning and AI, and then good grasp, like good grasp, because again, strong on the programming background because you can't. Like, how do you even want to do it? You can't. Core understanding because you need to know what's really good. You're not going to just, when some years back, right? When I took a session, I can't remember how many years ago, I was working with moms, and I was called on to facilitate a data science section to train them on data science and statistics. And we were going through the data science workflows and life cycle and the likes. And we're discussing. I told them, right, you're not going to be predict and fit data scientists. Right, the same thing applies to LM engineering and ML in the entirety scope of it. It's not about predict or fit, right? It's about understanding what are you predicting, what are you fitting, what is the mathematics, how does it work under the hood. It's not something you can just escape your way out of it, right? And then good class of statistics and mathematics, because again, all these things under the hood that you are coding with Python are mathematics and statistics working. Like, you need to know what they are. All right, so yes, allow me, the Lord is your strength, but don't worry, you have the strength enough to carry out through this session. That's why I went back to email. Don't worry, you are here now. You are here, Miriam. Don't worry, you walk through it. Which programming language should we require? Python is a start, right? But you know what's really interesting? Python is a start. Python is what they tell you it is, but Python is not what it is, right? Python is the start. Python is what they tell you it is, but Python is not what it is. I'll just leave it at that. Right? In the course of the session, I will distill what that means. Okay, so do you need a particular programming background or any programming background works? Not any. Not any. You can't do this with JavaScript. Sorry to JavaScript guys. If you're a JavaScript guy on the call, sincere apologies to you, right? You can't do this with JavaScript. Okay, Python generally okay. That's your opinion, T. That's your opinion. First and foremost, Python. Yeah, I mean, it's a good way to start, right? That's why they call it English language. I've been making Chiron, maybe. Okay. Do we need C? This Python is not what. Why does your day? What does your day look like at work? What tools do you use regularly? Okay. Interesting. Okay, so how about C or Java? See what math. Okay, so let me just answer Silva's question. So what my day really looks like, interestingly, right? Day to day is usually more client side before coding side, right? Client side means is right now I'm working very closely with insurance and reinsurance in terms of AI at scale. So my day to day right now is transferring domain knowledge into data science and AI, right? So that involves me sitting down with majority of the domain experts in terms of risk analysis, understanding what they do, how they do it, and what are their problems and limitations before my team now moves on to the coding part of it, which involves now building the solution for them, right? So it's usually my day is as at this stage in my career. Like initially, I was never involved in those parts. I was more of the coding. But right now in my career, my day is more involved with facing facing the clients, understanding them, then going back to with my team, and then refurbishing that knowledge, cleaning it up into the architecture and system designs, and then we start coding. All right. C++. I did not enter for LM, but this one is making me to have a little thing. Yeah, thank you too. All right. I think my time is up. All right. So my time is up, and I would like to end this session here. I think what I will do is for just 2 minutes, if you have any question for just 2 minutes, I think we can entertain 2 minutes of question, and then we can close the curtain from there. 2-minute question, and then perhaps we can close the curtain. So if you have a question, you can just use the chat, or that will only just happen for 2 minutes. Okay, what is your LinkedIn handle? Okay, I think I will share that. Thank you. Okay, question: where does hallucination come in if the API does generate new data outside its training data? Now that's a very good question. Are we going to look at mathematics behind LM on this course? I won't answer that question yet. Okay, so let me answer that next question. Where does hallucination come from? No system is perfect, right? No system is perfect. Hallucination is at the bed of it was initially considered AI dream when it was not understood. It was considered as AI dreaming until it was understood, and then we changed that name from AI dream to hallucination, right? Which is the reality of it. So hallucination in terms of this is an ALM has reached the climax of its understanding, and then it began to map data based on based on the available probability result that it is getting. So when a model is supposed to explain the theory of AI science, right? And then it got to a point and began to say something. Oh no, that's not good. Let me use RAG. I think RAG would be a very good example to this. So you ask an AI, right? What is AISOC about? It does not know AISOC. He has never encountered AISOC before in his training data. It began to regurgitate nonsense. Now, it is doing that based on to it the nearest probability weight that best answers that question, right? So, what's the AISOC? AI, SOC. SOC might mean, so it is doing a might. Hallucination is LM doing what may this be. So what may this be? But it's doing that may this be based on what it already knows, not based on what it is going to create. No, based on what it already knows. So an AI will say, okay, I know SOC might be an abbreviation of summer of code. And I know AI is artificial intelligence. If I bring this together, AI, summer of code. All right, let me start predicting. I predict that AI summer of code means a summer of code session that's teaching AI. I predict, based on my training data, that it is held in the US, which is totally wrong, right? I predict, based on my training data, that because AI, based on my training data, my training data has a lot of AI citation from Silicon Valley and San Francisco, this program must be held in Silicon Valley and San Francisco. It starts generating nonsense. But it's doing that based on the data in its corpus, in its data set, right? So it's assuming that it's not creating anything new. It's just using what it knew already before to fill in the blank and create that answer. Now that's where RAG comes in. You now bring in RAG, right? To say, okay, now this is the information. You were not trained on it. You were not trained on it. Because if it had the capability to create new information, it will not be wrong. It will not be hallucinating. It will be right, right? But because it is doing that based on the training data, and it is not new information, it is old information being reconstructed, it needs RAG, which is external knowledge, to come in and compensate for its dormant training data knowledge that it already has. I hope I was able to answer your question. When it comes to strong programming background, do do we have to know how to code off head, or we need to understand how code works? You need to understand how the code works. There's no magic bullet for anybody doing code off head. You just need to understand. Trust me, even senior engineers go to Google sometimes to type, what does this thing mean? Oh, CAG. Wow. Okay. So should I do that right now? I think what Solomon may be referring to is this, guys, context-aware RAG. I think maybe he may be referring to this context-aware RAG. But no, I think that's out of scope of this time. My time is already. Otherwise, if I go into that, I will spend a lot more time me explaining all that. Okay. When it comes to programming, because Python courses are just the fundamentals. Okay. What does it mean in terms of ALM? Okay, I think I already responded to that. I know Python is broad. Is there a way to narrow it down to ALM? No, Python is not broad. Don't come with that context, right? Don't. If you come with the context that a programming language is broad, you struggle to learn it, right? Don't come with the context that is broad. Come with the subject that you need to first learn the programming language like a software engineer first, which means that you need to learn about all the primitives that are available there, how those primitives are extended. Then you can now start saying you take it up from there. You talked about the other talk. Do we need strong deep learning for LLM? Yes. You need deep learning knowledge for LLMs. It's really, really good and important. Okay, I think I will draw the curtain from here. It's only 14 minutes past time. And then we can catch up in the next session as the program goes on. All right, thank you so much, guys. Super excited to do this with you. And my name is Sam Ayo, as always. Cheers.